Right, so we have shown how you can go about doing your two-sided test. It just means that you have two shaded areas in your students' T distribution. Knowing the degrees of freedom and the level of significance, you can easily compute your you can easily complete the test. Now let's look at a more realistic case in economics, which is the one-sided test. In most cases, economic theory is very clear about the direction of the effect of one variable on another. In that case, we don't need to formulate a two-sided test. A two-sided test implies that there is some degree of ambiguity. We are not quite sure whether education would turn out to have a negative or a positive effect, but human capital theory is very clear on the effect of education. So our null hypothesis will, as usual, deny what theory says. Now, when it is a one-sided test, you can adopt a stance. There is no hard and fast rule, but you can adopt a stance where you still state that education has no effect. Okay? Or you can say, I'll show you the two ways, right? Co-F of education equal 0, that it has no effect. Generally, econometricians want to test this point against any form of alternative hypothesis, or you could say co-F of education less than or equal to 0. Okay, now the less than part here doesn't make much sense because there is no way education can ever have a less than 0 effect, less than a negative effect. But obviously, testing the point 0, if we are able to reject the null hypothesis at the point 0, then we have rejected it for every other point to the left of 0. That's the idea. So stating it this way or that way really doesn't matter. So our H1 will say coefficient of education is greater than 0 because theory tells us that education has a positive effect. Hence, we are now saying greater than 0 there. Let's say that our level of significance is still 5%. Then we must find our T critical values, which this term is going to be 48 degrees of freedom, 0.05. That term, the tail was divided, the level of significance was split into two because we had two tails. But now, since it's a one-sided test and it's an upper tail test, so the entire 5% will be in one shaded region, not half of it. Okay? And then we will see what we will get there. Let me put an equal sign. Then we must state the decision criterion. If T ops is greater than T critical, reject H naught. What does greater than T critical mean here? It means that it has fallen into the shaded region. Okay, reject H naught, otherwise fail to. Okay, so now in our T ops, we already calculated it. There it is, but you remember how it's calculated? It's coefficient over its standard error. So we have it calculated 3.58. Okay, so what's the critical value here? We want 5% in one tail, so we come here to our table. The upper row tells us the area in one tail, so we want 5% in one tail, which is this. So we come down all the way to 40. Because we don't have 48, the number nearest to 40 is to 48 is 40. So there we go. Where is my mouse? It's hiding. It's that number there, 1.684. Do you see that? 1.684. So our critical value is 1.684. Okay. Now the next thing is to make our decision comparing what we observed, which is the test statistic, versus the critical value. Okay, so since T ops is greater than T critical, reject H naught and conclude that education has a positive effect on earnings at the 5% level of significance. You are done with that. Okay, we are done with that. But now let's suppose that for some reason, this is just to illustrate, but actually it doesn't make much sense. Or maybe I could change this into a demand function for illustration purposes. Let's say now this was QD is equal to, let's take whatever we have there. Let's remove the minus sign there and call it 3.402, and let's put the minus sign on the slope coefficient 0.816 price. Okay. Let's say this is the regression we had estimated, and again we are going to do a one-sided test. Okay. Now we formulate our null hypothesis. Our null hypothesis will say coef of price is equal to 0, or if you like, you can say greater than or equal to 0. Okay, we are denying what theory says here, or you can just state the point coef equal to 0. There is not much difference there because the entire test is premised on the alternative test. The alternative hypothesis determines the structure of the test. So H1 states what theory says. The law of demand claims that there is a negative relationship between price and quantity demanded. So it will say coef of price is less than 0, which means it's negative, right? So with that in mind, then our T ops, we need our T critical first. Our T critical will be equal to, from what we have already done so far, saying all these 50 people are what we were looking at. So now, because the alternative hypothesis is talking about the negative region, the critical value in question will still be the same number, but this time it will have a negative sign. Okay, so it's a minus 1.684 rather than a 1.684. Okay, so it will be minus 1.684. Oh, look at what I've written. I'm now saying 864. 684. Okay. And now, assuming a 5% level of significance, of course, and your T ops is now minus 3.58, remembering that your slope coefficient is negative now. It's negative there. So this number will be a negative number. So now, our decision criteria says if T ops is less than, notice what I've stated there, is less than. That time I said greater than because we were talking about the upper tail, okay? Is less than T critical, reject H naught. Otherwise, fail to. Now, why do we have to reject? Because a number which is far less than, which is less than minus 1.684 implies that we are in the shaded region, which is the rejection region, okay? So then what do we do? Based on the information we have there, we can now say since T ops, which is minus 3.58, is less than T critical, which is minus 6.84, reject H naught and conclude that price has a negative effect on quantity demanded. Notice that my conclusion has direction of effect. My conclusion has a direction of effect in this case because my alternative had specified the direction of the effect, okay? So this is all about hypothesis testing. The other thing you can do is to construct a confidence interval, which we call interval estimation. Now, this idea of testing the hypothesis based on a particular value of the estimate sometimes might be very misleading, you see. Point estimates are very misleading. So what we generally do is we want to construct a range of values that have a certain probability of containing the true value of the beta or of the population parameter. So what we do is to say estimated, so your confidence interval is given by your estimated coefficient plus or minus your T critical times the standard error of the estimated coefficient. So this is how you calculate your confidence interval. Now let's say we want to calculate the confidence interval of education at the 5% level of significance. Then we are going to do it this way. We will have the coefficient of education was 0.816 plus or minus. We got a t value of 2.021 times the standard error was 0.228, and then we want to find out what happens. You will get something like this. There will be 0.816 minus 2.021 by 0.228. So we will have 0.355 and 0.816 plus 2.021 times 0.228, 1.337. Now, bearing in mind, for example, that your earnings are measured in thousands, so you will have to multiply by 1,000. So what you're saying is that the 95% confidence interval is given by 355 rand less than true population beta 1 less than 1337. Okay. Now, but what would have generally happened is that we would have formulated a two-sided hypothesis which says coefficient of education is equal to 0. Okay, so then the question we have now is to check whether this 0 actually lies between 355 and 1337. The fact of the matter is that it doesn't lie between the two. So since what have I done here? Right, so since the point beta equal to 0 lies outside the confidence interval, the 95% confidence interval, reject H naught and reject H naught. Okay, so in other words, this confidence interval is an alternative way of testing the same hypothesis that education has no effect on earnings, but instead of us testing it around a particular value, we construct a range of plausible values within which the true effect of education on earnings might lie. And we are saying any number between 355 and 1337 could be true. Could any of those numbers, one of those numbers in there could be a true measure of the effect, a population measure of the effect of education on earnings. Okay, essentially that's what you will be doing. So understanding, all you need to understand here is how it is constructed, and you run with it, and you will always be able to answer the necessary questions that require you to construct your confidence intervals.